Hello everyone, Federica here. So today we are going to have a look at a new feature of RStudio, and so we produce summary using Quarto. Hope you enjoy this new venture, and so I'll start sharing my screen. Okay, this is our studio, and we are streaming with Restream, and we are in the RStudio Data Analytics best practices. Okay, as you can see, these are all the files that we already pushed into our repository, and so all nice and sound. So what we are going to do is to have a look at some very simple statistics and produce a summary with a Quarto document. So here there is a list of files, so you can select Quarto document, and we can specify the name, what type of we want. So, but for now, we just create a document like this. Okay. So this would be untitled. So we need to give it a name, and so as you can see, we are in the visual of this, so we can see basically this is a new feature, so we can see more or less the output of the file. While if we click on source, we go back into like the same as as in what we have seen in our Markdown. So we have chunk of code, and where we can add our written information. Okay, just the difference that we are on Quarto, so we have a little bit more like facilities. So it based on our Markdown, but we have more facilities. First things that we do, obviously they can survive together. So we can have in the same repository both our Markdown and Quarto documents. So we can we could add the document from here, and so that will have been positioned in, automatically inside the project. But we want, in that case, have this initial part of the file, which is a very important part. It's called YAML type of syntax, which is readable by Quarto or R Markdown, and it gives basically the structure of the file. In fact, if I do just Quarto from here, so just leave it like that, and produce a new file. So I have the Quarto file here, but it is nothing in there. So we don't need that. So we just trash it. Okay. And so now this is our document. If we might need to save it inside our project. And so we save it here as 06 Quarto basic statistics. Oops. Let's rename it. Stats. Okay. Oh, let's do it again. Rename it. Okay. So this is our document. In the YAML, what we, the same as we did it last time. So now we have 6 documents here. This is the very, first part of the document. As if we have a quick look at our Markdown, so it's basically the same thing. So this defines the YAML language. Okay, and so we can customize this. So we are on Visual, we go on Source, and so we can customize this thing. What we want to do, it's basically, let's give it a title, okay? And so we name it something like measure of central tendency, just to give an idea of what's happening in there. This will be the title of our document. Obviously, it doesn't get into the meaning of having another name within the project, because even if when you produce more than one file inside a project, this is your personal reference of the files. So while this is the title of the document, the particular document. We are not interested in producing a HTML format. Instead, what we want to do is have a PDF. Okay, release a PDF. We can even leave the editor equal to position it to visual. So anytime we do click on visual, we can see what would be the output. And this is the format that it would be basically the output of our file when we render. Because on Quarto, we have, instead of, if we go back on the Art Markdown, instead of having the neat button and different options here we have the render button. So even if we click on the gears, so this is nothing similar to what we can specify in here, but you need to use like a specification inside the YAML part of your document. Then I'd like to add a bit more information, such as here I can like set all the information that I've got. I usually set here in one R Markdown. So when I set the options that will affect all the following chunks, all the chunks in the document. In Quarto, I can specify them in the YAML. Okay, so for example, I still use the meter package, just as the same as here, but it's specified in the YAML. And then I can specify the option for all the chunks, and then I like select some options. The last 3 options are what we already used in the other documents, so no messaging, warnings, or so this is echo false, while here we have the echo true. So that means that when I do I execute a chunk, the code of the chunk will be printed out in my document. So I can show the code. Instead, now I don't want to show the code. Okay, so I put echo false, and then comment equal to this double quotation. So empty quotation is something else that I'll show you later, and so the collapse true. We can close these outlines, which is the skeleton of our document that we are going to build now. But for now, this is our PDF that we are going to make. If we render the document and we are going to see it in preview, the output of this document in the viewer pane. That means here in the viewer. If I render this bit just as is, we see that it's because of the connection, it takes a bit, but instead it is usually very fast. There is nothing in the file, quite empty. So it takes a bit, but and it releases some extra files, as you can see. Okay, because it's compiling all the information of this type of files, .qmd. Okay, so the connection maybe doesn't help us very much. Okay, so this is the output. So as you can see, it's a PDF file. We have a title, and so this is what is inside the document. So the standard document when we produce it. So we need to make some modifications. As you can see, this echo false, what allowed us is to hide this 1+1, for example, in the chunk of code. So we don't see the what is the background, so what's happening behind the scene of this number 2. Okay, and this is nice because we can produce a document for management and everything without any, for students in this case, because we are talking about basic statistics, and but we don't want to show up the code. Okay, what else we do? So now we stop this to run because it is now produced. We don't look at this for now, and we go back to our file, and we start building it up as we like. So we might want to. So we have this title, and so we say set an overview, and we write some few things, okay, in there. Such as I don't know, something like, this is the vector of numbers for which we are going to calculate the measure of central tendency, and which is a set of measure classed as summary statistics. Okay, then we don't need all the things that are down here because we need our information. So we add the chunk. We can go here in this green button, and so the chunk is produced, or as well as we did it, all come by, and we produce the chunk. Instead of in R Markdown and add the options inside the R parentheses, we specify the option in here with an hashtag and a vertical bar. Okay, so now we can write all the things in there. If I want to show just for this chunk the code, I can specify equal true. As you can see, the difference with the arc markdown is that if I go into a chunk and it says like evolve equal to false, instead here I do the colons instead of having equal, and true is in lower, not capital letters. Okay, so what I'm going to write here is like a vector of numbers, just easy as that. We have some numbers like 8, 9, it's like 8.8, 9.5, and so on and so forth. So if I run this one here, I can even such as make some, have a quick look at what is the length of h. I assign to this vector of numbers, okay, a name which is h. So I have a look at this at length, and the length is 25. So we have 25 numbers here. Okay, so we could do many things, such as having a look at these numbers and everything. We can use, for example, the plot function, h, and see what's happened. Do plot function and then h. It takes a bit because the connection is not okay. So we see that our numbers are these are the numbers, and these are the, so for example, we have 5 of these things. Okay, some of them are repeating themselves. Okay, I can even order this number around 20, but you can see we have some numbers here. Okay, if we don't, and here in this case we have used the plot function. If we want to use ggplot, we need a data frame. So we might want to put this inside a data frame, such as doing, for example, IBO or data frame. So new as data frame, we put h, and this would be our vector. Okay, and then we can use ggplot. We need obviously load the library. Use directly tidyverse because it contains more packages that we might need. It shouldn't add all the information that usually comes out with when loading the packages, because this has happened when we need, so we rendered the document because we put this warning false and message false that affect all the chunks. So then we can do, we have this as a data frame, and then we can do like a ggplot, and we use just the h, and then maybe do a histogram. Okay, so we can see what are our numbers distribution looks like. Okay, so all this is fine. We can have a look at the write some things like the vector of numbers. This one here. It has a length of, and it will it will show that just the number, because the echo is false for all the chunks except this one here. Then we can say look on H, and then I want to, if we select the H and then we do Alt, Command, and 9, and then space, oops. Okay, so if I do Alt 9, there is this backtick that basically it's used to put inline codes. So this H will be in the output, like evidenced as differently as the other part of the text. So have a quick look at the distribution of H with a scatter plot. Like using the, and again, backtick, plot, backtick, function. So we can do that, and then load the necessary library and make a data frame to produce a histogram with ggplot. Okay, so histogram is done. And then we specify this ggplot package. Okay, so this will be like added, and we have just the outer. We can even add a little labs with the title where we write distribution of H. Maybe color it a bit and do like we add a caption and we say RStudio Lab series. Quarto. Okay, this is a Quarto document, and then we may want to color this as a still blue, and then make a nice team in 558, 38 team, and then we want to maybe do the same as like white and fill. Okay, so this is we save it automatically. Then we want to do a bit more. Okay, so we'd like to talk about the central tendency. So we have a look at this. The measure of the central tendency is given by the mean. Okay, and then we might want to add like a formula in order to do that. We do like this dollar four times dollar sign. And then we want to write mu. So as you can see, this is the mean. And then if we want to add a bit more, like what is this, the formulation of the mean, we do frac for fraction, and then we add like the sum of all the values that goes from 1 to 25, that go from 1 to 25. And so it's better if we do like e equals to 1 to power 25. Maybe that is not and equal 25. We have e that goes from 1 to 25. And then what is the sum is x of e, a b, and then divided by n. So this is basically what's happening in there. Okay, so this is we have built a formula, and this language is the LaTeX language for making formulas. We can, with a little customization, write nice formula in here. And then we can even add a bit more information, such as and the mean in n is equal 25, and the mean is, and so here we calculate the mean of age, which is 9.652. If we render this document now, it will be appearing here with this formula, which is very nice. So nice and clean and all good. Takes a bit. In time, we might want to add more information, such as not only the mean, but we want to add like the variance of this. So the measure of the central tendency here is given by the mean. If we do this stars means we want to this bit of text in bold. So as well as we do maybe with the variance instead of having the backticks. Apparently it takes a bit because it's, and so as well as before, we add the formula for the variance. There you go. Okay, so this is the overview of our document. As you can see, this is the output. It is a PDF file and all the other things. So you can reduce the size of the images or put them on a site with different options. But for now, we add a bit more information that we finally customize. So here we have the formula for the variance, which is sigma powered 2 by 2, and then the frac as we did it before, and then the sum sign that goes from I1 to 25, which is this bit here. And then what is the x sub I minus hat, this hat, the x, all powered by 2 divided by n. So this is the formula. And then, so we calculate the variance. That's the variance of H. And so this is the variance that will be appearing there as the same as here. And then what else we can specify is the sigma, the standard deviations, for example. So we can like add more information, say the standard deviation is the square root of the variance. And so we do the same thing, but we add the square root. Seems like obvious things, but they are not sometimes very useful. So how do I calculate the standard deviation? I use SDH. And here is the standard deviation, which is the square root of the variance. And then finally, I have the coefficients of variation, which I put it there, coefficient of variation. And this is the C sub V is basically sigma divided by mu. And I can do this safely in R, just as simply as dividing SDH divided by the mean H. Okay. So I got this value, and then finally, what I want is the confidence interval. And here this time we, to calculate the confidence interval, we use the standard deviation and then the square root of the length of H. And we have this the value here is standard error, which is the standard error. Then we set an alpha equal to 0.5, and then we might want to define a little length, which is useful for what we want to calculate. So this time, basically, this is something that it's safe to do. So the degree of freedom basically are the length of the vector minus 1, because 1 is basically taken on a side. And so the one of the variable is basically one of the observation is taken, while all the other ones can vary. So this is the degree of freedom. And then we can even split all the things within chunks. So we have the information appearing there. Because I'm not, let's write this like such as this. If I do alpha, I have the alpha, and then I put equals to 0.05. I don't need this to be seen. Then I have the degree of freedom, which is, oops, I didn't 24, and they are the degree of freedom. And then what else we like to add? So we have this other things that we need, which is the basically the, okay, let's have a look at this, QT, okay, in Basal. This is the so basically we can calculate the quantiles in here. So we specify basically the amount of the distribution. So we have a distribution here, okay? So we have we like to basically have the most of the information except details. And so we like to have like 95% of information. And then we leave aside 2.5 and 2.5 of the information at the sides of the central tendency, so the distribution. And so we do a T, the students, and to do that, we do like we set our alpha, we specify the probability, we set our alpha, the degree of freedom, and then we want the lower tail. So just one tail. And so basically, it would be 97.5% of we retain the probability, and we leave just 2.5 aside. If we run all the things, okay, now I'm running everything back, but it doesn't matter. And then we run the TD of students. Okay, so this is our value, which is about 2. Okay, and now what we need, it's basically adding 2 more informations, which are the lower bound, the upper bound. And that would be the mean of H minus the error, mean error, and the mean of H plus the mean error. So I have the low, oops, I didn't, where is the mean error? I didn't set the mean errors. Okay, yeah, of course. So the mean error, I didn't set the mean error. Okay, so the mean error will be our t distribution value times our t value times the standard error. And this is the about 0.3 that we use this to specify the lower and the upper bound. Then we can use this notation like lower bound semicolon upper bound to see what the values are. 9.36 and 9.94. This is why the mean was 9.65. And so now what we do is basically having a look at what is if we put them in a data frame, we do a quick model, we verify that these are the values that's calculated. Okay, so we do a data frame, we set a length from 1 to 25 by 1. Okay, so we have our data frame HH, I call it HH, which is exactly the same as before, just we have an index vector. And then if we apply a linear model, okay, we basically calculate with a simple formula set on 1, which is more specific explanation of all this would be elsewhere. But we assume to just evaluate veridicity, the confidence interval that we had just calculated. And so if we have a look at the model result, so the summary, we see that we have some information, the coefficients that we have just, which is just the mean, okay, because we haven't any other information, as well as the minimum and the maximum values. And so we can calculate the confidence intervals at 95% level, which is this. Okay, so this is done function. And set this. And so what's happened here is that we end our session with a little visualization. And so we like to add this information in our histogram that we can do with base R. And so we can see our information the same as before. It is now clearly identified. So we have the mean here and the confidence intervals there. Okay, so we render this document, which is now a nice PDF that can be customized nicely with like reducing the size of the images and positioning them maybe on a side or put them on the two two of them on the same row. All things that we can explain and do nicely. And so just we wait. Let's see, a few more minutes to give Quarto and the connection the time to compile all our information. And then we can see what we have nicely produced with a PDF file. This file will, as you can see, we have lots of files, but as soon as ends the compilation, might takes a bit. Those extra files are not needed anymore, so you might left. Okay, now we have produced 5 pages, and we might want to maybe reduce them a bit, customizing the size of the images. As you can see, this is all our information that we put, and then finally we have the histogram, all nice and sound. And this is the, as you can see, all the files disappeared. We don't need it, and we have a nice PDF file in here that we can use, and our Quarto document. What we do now, before to end this, we close this one, is to push everything to our GitHub repository. And how we do, it's clicking on commit. I'm not sure you can see this because I'm sharing just RStudio, but basically what I'm going to do is to just select these 2 files, 1 and 2, click on commit. The page to commit appears, so I set updating 06 Quarto and commit. So then pull down. We can even do it from here. So we pull down and then push up. And so all our information is gone, it went on our project. Thank you very much. And I think it's everything for today. So I'll see you tomorrow for further improvements on producing summaries using RStudios. Bye now.